My name is Keshwani. There's Keshwani. Keshwani. We are here because we want to prepare for GMAT. We have been solving GMAT math problems out of this book here, GMAT Review, the official guide to 13th edition. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 290. Today is our lesson number 222, problem number 159. Let's take a look at it. Problem number 159. In the first column, we are told that x is an integer. The question simply is x times the absolute value of x less than 2 raised to x? Very interesting question here. Let's see what they tell us. In the first statement, they tell us that x is negative. We are told that x is less than 0. Well, let's see what we can do with it. X times absolute value of x. Even if x happens to be negative, by the time we take the absolute value, which is the whole point of taking the absolute value, this quantity is going to become positive. And x, we are told, is negative. So this is going to be negative, which means x times absolute value of x is going to be some negative number. What about this guy? 2 raised to x. If x is negative, all that means is that this quantity is some fraction. It's some fraction. For example, if x happens to be negative 1, we are told that x is negative. If x happens to be negative 1, 2 raised to negative 1 is simply 1 over 2. If x happens to be negative 5, it's just 1 over 2 raised to 5. If x happens to be negative 37, it's just 1 over 2 raised to 37. It's a very small fraction. It's a very small fraction, something very close to 0, but nonetheless, it will never turn negative. It is some fraction. It's an integer, which means we know now that the smallest value it can take is going to be 1 when it's negative 1, which is 1 over half, 1 over 2, then it's going to be 1 over 4, then it's going to be 1/8, 1/16, and so on and so forth. But it will never be negative. It's going to fall from here to here. Here's our 0. Here's our negative 1. When x is negative 1, it's going to be right here, negative 1/2. When x happens to be negative 2, it's going to be 1 over 4, right here. Not negative, positive. This is all wrong. This is all wrong. 0. That's the whole point. Whole point I'm trying to show you here is that it's some positive number. When x is negative 1, it's going to be 1 over 2 raised to 1 or half. When x is negative 2, it's going to be 1/4. When x is negative 3, it's going to be 1/8. And then 1/16, and 1/32, and 1/64, and so on and so forth. The highest value it will take is 1/2. But it's going to be somewhere here. And of course, by the time it reaches infinity, it will actually approach 0 asymptotically. Never quite in reality. But even then, it will never be negative. So we know that this quantity is always positive. The question was, is this quantity x times absolute value of x less than 2 raised to x? The answer is yes. The answer is yes. Is x times absolute value of x less than 2 raised to x? The answer is yes, because the answer is yes, because this is positive, this is negative, negative times positive is negative, whereas this is always positive. Positive, whatever this quantity is, a positive quantity is always going to be more than a negative quantity, obviously. So the first statement does the job. The first statement is enough. A, D, B, C, E. Of course, we just found out that the first statement by itself does the job. We know now that the answer, whatever it is, has to be either A or D. It cannot be B, C, or E. Let's look at second statement. In the second statement, they tell us that x is negative 10. This is interesting. Is that right? 159. Yeah, x is negative 10. What do you know? Oh no, let's see what we can do with it. X is negative 10. They actually give you the precise value of x, so that makes it easy. So it's x times absolute value of x. This is positive 10. This is going to be negative 10. So this quantity we know is negative 100. That makes our life much. Again, same thing. By the time you do this, 2 raised to negative 10 is simply 1 over 2 raised to 10, which is a very small quantity, but it is positive. It is positive. So this guy again turns out to be positive. This guy is a negative 100, and therefore positive is going to be more than negative. So the second statement also does the job, and therefore the answer is D. The answer is D. Second statement by itself is also sufficient. Let's see what we have next one. You want to do one more? Let's do one more, shall we? Number 160. Let me quickly take a look at the clock in the back. I'm still here. I'm not leaving the room. Yeah, let's do one more. 160. We're told that n is positive. Not only positive, but it's a positive integer. Question is b minus a at least twice the value of 3 raised to n minus 2 raised to n. How do we write this mathematically? Mathematically, it simply says b minus a is it at least twice as big, has to be greater than or equal to. It could be equal to or greater than. This quantity has to be either greater than or at least equal to 2 times this quantity, 3 raised to n minus 2 raised to n. And that's the question here. That's the question mark. Let's see what they tell us. In the first statement they tell us, that a equals 2 times or 2 raised to n plus 1 and b equals to 3 raised to n plus 1. All we have to do is substitute the two things. Let's substitute in here. Tell you what, I'm going to start from the top here so that we can work our way down. It's going to be too low here. Let's substitute in here. So b, which is 3 raised to n plus 1 minus a, which is this guy, 2 raised to n plus 1 is this quantity. What we want to find out is this greater than or equal to 2 times 3 raised to n minus 2 raised to n. Let's find out, shall we? Well, this 3 raised to n plus 1 is same as 3 times 3 raised to n. Of course, therefore this is 3 times 3 raised to n, and similarly this one is 2 times 2 raised to n. I'm not sure where it's going to get us, but oh, I see. And then let's open this side here. So here we get, again the question mark still stands, is 2 times 3 raised to n minus 2 times 2 raised to n. So here we have 2 times 2 raised to n, here we have 2 times 2 raised to n with the same negative sign, so this drops out. If you were to add that quantity to both sides, it will drop out. So the question now simply is 3 times 3 raised to n greater than 2 times 3 raised to n? Of course the answer is yes. Again, because we can either look at it the way it is, or again, if you divide both sides by 3 raised to n, which we can perfectly do that because 3 raised to n is some positive number, and as long as we divide both sides of the inequality by the positive number, we don't have to worry about reversing the direction of the inequality. So this drops out. So all you have to answer is 3 more than 2? Of course it is. The first statement by itself does the job beautifully. The first statement works. First statement by itself is sufficient. A, D, B, C, E. Because we just found out that the first statement by itself is sufficient, we know now that the answer cannot be B, C, or E. It will have to be either A or D. Let's look at second statement, shall we? In the second statement, they tell us that n is equal to 3. Well, n is equal to 3, what it is going to do is allow us to figure out this value. 3 times 3 raised to 3 minus 2 raised to 3. This we can very easily figure out. 27 minus 8 times 2. The question is this quantity less than or equal to b minus a? But we have no values of b's and a from there. It gives us the value of n, but it doesn't give us the values of b and n. What are the values of b and n? It doesn't give it to us. Therefore, second statement is not sufficient. Therefore, the answer is A. The answer is A. That's it. I'll see you tomorrow, okay? Bye now.